Alright, welcome to this page of the notes. What we're going to do here is again look at a couple more properties of equality. These ones you are very familiar with. The first one is simply the addition and subtraction property of equality, and all it says is that you are allowed to add anything you want to one side of an equation as long as you do it to both sides, right? So you need to think of the equation, the equal sign, almost as a scale, right? And if you're going to add something to one side of the equal sign, if you're going to add something, in order for that scale to be balanced, you must add the same amount to the other side as well, so that the equal sign is both sides are always equal. Same thing with subtraction. If you take something away from one side of the equation, I take something away, I must take the same amount away from the other side as well, so that both sides are balanced. Right? That's the addition and subtraction property of equality. You can do anything you want, add or subtract anything you want from the equation as long as you do it to both sides. The exact same thing is true for multiplication and division. You can multiply or divide anything you want from the equation as long as you do it to both sides. You must do it to both sides of the equation. So let's go ahead and get a little bit of practice trying these. Feel free to run ahead, come back and check your answers, see how you did. So here we go. The first one I've given you, I want you to solve for the variable. We have n minus 3.24 is equal to 42.1. Well, I need to get that n by itself. I need to isolate the variable. In order to do that, I'm going to need to take this negative 3.24, move it to the other side. Since it's a negative 3.24, the way to undo subtraction is going to be addition. So we will add plus 3.24. But whatever I do to one side of the equation, I must do to both sides. So we will add 3.24. Now, when I add a 3.24 to a negative 3.24, they cancel each other out. I'm left with just an n. I have isolated my variable. On the other side of my equal sign, I now have 42.1 plus 3.24. Grab a calculator, don't fat finger something on the calculator, and you should, let me write that one last step. I now have 42.1 plus 3.24, which is, according to my calculator, 45.34. Let's go ahead and try the next one. I'm going to need to isolate my variable. I have a negative 5/8 times x divided by 20. I need to get rid of the negative 5/8. I'm going to do this two ways, all right? Now, we're going to try both methods. If you like one better than the other, please feel free, pick your favorite way if one just sort of fits your eye better than another. Here we go, the two ways of doing this. Method one. And then over here, I'll do method two. Let me rewrite my problem here for method one. So I have negative 5/8 minus 5/8. X is equal to 20. Now, here's what I can do. I recognize that in this fraction, negative 5/8, I'm dividing, right? I have division by 8. The 8 is in the denominator. Well, how do you undo division? Multiplication. So if I multiplied an 8 on both sides of the equation, the 8s would cancel on this side and move it to the other side. So let's go ahead and do that. I would have minus 5. X is equal to 20 times 8. Right, I've multiplied an 8 to both sides. The 8s have canceled on this side of the equal sign, moving effectively the 8 over to the other side. I go ahead and do 20 times 8, you get 160. Now what I can do is, since I have multiplication by a -5, x times a -5, well, the way to undo multiplication is division. Let's divide both sides by -5. And 160 divided by a -5. If I put that in my calculator, I get -32. So there we go. We have solved this equation, taking care of this fraction by recognizing I can move the 8, which is divided, by multiplying it, and then I can move the 5, which is multiplied, by dividing it to the other side. Okay. Method 2, and I will say this, if you were to ask me, Mr. Orange, which method are you going to use? I'm always going to use method number 2. Let me put a little green star next to it. It is faster. I like it better. It's a much more, this is a little middle school, this is a much more high school way of dealing with this particular problem. So here we go. Minus 5/8 x is equal to 20. Here's what you might recognize. You'd be like, hey, I'm multiplying by a -5/8. I'm going to take care of the whole thing at the exact same time. Since x is multiplied by a -5/8, I'll divide by a -5/8. Let me put that in red. Divide by -5/8. But whatever I do to one side, I must do to both sides. Now, what happens over here on the right? -5/8 divided by a -5/8. Any number divided by itself is 1. And so what I wind up with is those guys canceling each other out, and I'm left with just the x. That's exactly what I wanted. I wanted to isolate my variable. Let me rewrite the other side. 20 divided by -5/8. And let's get a throwback to middle school here. In middle school, you would have learned a cute little phrase that allows you to deal with these complex fractions. It's called keep it, change it, flip it. You're going to keep the numerator, you'll change the division to multiplication, and you will flip the denominator. So x is equal to 20 multiplied by a -8/5. Please notice, this is exactly what we did over here. We multiplied the 20 by 8, then we divided by a -5. Over here, you will be multiplying the 20 by 8, dividing by a -5. We get the exact same answer. X is equal to -32. This way is just, I think, a little bit quicker because you don't even necessarily need to show all of the steps that I showed to be complete in showing your work. But it just takes care of this -5/8 in just a little bit neater way. So this is almost always the method I will use when solving these. All right, let's go ahead and move on to the next one. I have plenty of space here because this is a really easy problem. Let me do it in a different color for you, though, so we don't get them mixed up. Let's go ahead. I got a red here. So what I've given you is x minus 14.29 equals 25. Well, since I'm subtracting 14.29 and I need to move it to the other side, I'll need to add 14.29 to both sides. Let's go plus 14.29. Again, you got to think of the equal sign, right, as a scale. And if I add something to one side, I have to add the same amount to the other side. So I need to add 14.29. to the other side of the equation as well. What that's going to do is that's going to leave me with x is equal to 25 plus 14.29. Go ahead and grab a calculator, throw that in your calculator. Don't fat finger something on your calculator, and I get 39.29. Awesome. Let's go ahead and give this last one a try. What we're going to do here is we're going to go ahead and we're going to go with this method number 2, because once again I've got a fraction here, so we're going to do method number 2 to solve this one, just to get a little bit of practice with just that a little bit more advanced technique for solving these equations. So here we go. I need to divide both sides by 32. Since it's multiplied by 3 halves, sorry, 32. Multiplied by 3 halves, I will divide both sides by 3 halves. Now, because I have 3 halves divided by 3 halves, those guys cancel each other out, leaves me with just a y. On the other side, no need to rewrite this. It's the middle school keep it, change it, flip it. You keep the negative 18. You change the division to multiplication, and you flip the denominator. So instead of 3 halves, it'll be 2/3. Throw that into your calculator. Don't fat finger something on your calculator. You should come up with minus 12. It's a great review of some of the ways of solving an equation you guys would have looked at back in Algebra 1, both with it adding and subtracting things to both sides, or multiplying and dividing things to both sides. That concludes this page of the notes. Head on over to the next page. I'll meet you there.